This is about 2/3 of the way through the paper. All right, so just the last third to go. And we should know that from our use of fractions. 3/3 minus 2/3 is 1/3. I really wonder if anyone's ever going to watch these videos. Some of the jokes in these videos are terrible. Anyway, I do love the way as well that these questions are dressed up. Brilliant. The pendulum of a clock swings along an arc of a circle. I wonder if people even realise this is, we used to get, the grandfather clocks, the tick tock that used to be a kind of pendulum. I wonder if people have even seen that. It's, changing times. But anyway, so yep, tick tock, a grandfather clock. This would go left to right, and that would work the mechanism. Let people hear the seconds. Anyway, the pendulum swings to an angle of 65 degrees. It travels from A to B. Calculate the length of the arc is AB is 28.4. Okay, calculate the length of the pendulum. Okay, so it wants us to calculate this length here. Okay, fair enough. So usually, actually, it's arc lengths they want you to work out, but this time it's the pendulum. That might make it a little bit tricky for some people. They might think, "Oh, what am I asked to do here?" Well, think about it. You've got an arc, okay? You've got an angle. Now, there's only one equation that really fits what we're going to do here, but if you were to think on that as being part of a circle, yeah, would that make it clearer? So we're going to be thinking about, well, circumference is pi d, yeah? An arc length is pi d, but times the ratio of the angle that we're following through, okay? So that's the equation we should be thinking about. Okay, arc length is pi d times the ratio of the the angle. So first things first, I would do the theta over 360. So I'd say, okay, well, pi d times 65 over 360, and that's going to equal arc length of 28.4. Okay. Yeah. Now we want to work out d. Because we'll use d to work out the radius, and that's probably why you're getting 4 marks instead of 3, because if you think of this as a circle, the pendulum is effectively the radius of the circle. Okay, but yeah, first of all, you're thinking, what equation am I using? It's going to be an arc length, kind of pi d type thing. I suppose at this point you could actually rearrange that to say 2 pi r if you wanted, but I'm just going to leave it like this. Okay, so yeah, I think let's just turn 65 over 360 into a number. Okay, so 65 divided by 360, so 28.4 is equal to pi d times 0. Just say 18. Okay, now let's rearrange to solve for d. Okay, so how do I get pi over to this side and 0.18 over to that side? So I'm doing pi times d, and I'm doing times by 0.18. So they're times on this side, so they'll be divided on the other side. Okay, so that's going to give me 28.4 divided by, where my pen's gone. Oh, I can't touch on that side of the paper. Oh, I didn't realise that. Okay, divided by 0.18 pi. Okay, so if we solve that, what's that going to be? 28.4 divided by pi times 0.18. So that's going to give us 50.222. So at that point, I think a lot of people would stop and say, well, that's the answer. Okay, but we need to divide that by 2 because we're saying, therefore r is equal to half of that. So that's going to be 25, I'll just say 25.1 centimeters. Doesn't ask us to round it in any particular way. Chances are it's 25 is the answer. Let me see. Yep, that's what my marking scheme's got. So just because of rounding, because I've worked this out as an input, just on its own, I've got a slightly off answer, but you're still getting full marks for that. That's fine. You could have quite happily, if you wanted, rearranged at this point to be very precise. So if we really wanted to, and I can't be ultra precise, we would have just said 28.4 times 360 divided by pi times 65. That would have given us the most accurate answer. Okay, that should probably come out as 25 on the button. Okay, well then divide that by 2 as well. So you'd almost be putting your 2 in here as well. Okay, equals r. You could have done that. That's totally fine, right? Totally fine. But I've kind of done it in bits and pieces, and there's nothing wrong with that. You get full marks. Okay, so your first mark you're getting for this part here, 65 over 360. You're getting your second mark for doing the rest of the equation. Okay, so the rest of that's worth another mark. You're then getting a mark for rearranging the equation to D. So that would be this part here, and then your final mark for actually answering the question. All right. So not a particularly tricky question when you think about it, but I can see why people might not instantly associate it with that because they don't see a circle. You know, whenever you see the full circle, people always think, ah, okay, I know this. But they've given you a pendulum, and maybe folk would start looking at triangles and all sorts. Okay. That's interesting. You probably could you have drawn a line between here, and then you'd know the three angles in one line. Don't think so. There's possibly another very clever way of doing it, but yeah, this is what we're looking for. All right. So remember to answer the question. Bit of rearranging, but this is the, as I said before, this is the only equation you're not actually given. Okay, it's C circumference is pi d, and then know that the arc length is pi d times that fraction of the circle, the theta over 360. Okay, so please remember them. You're not given them. All right. Question 11. The top of the table is in the shape of a regular hexagon. The three diagonals are shown as dotted lines. Each have a length of 40 centimeters. Calculate the area of the top of the table. Oh, this actually looks quite interesting. Okay, so the three diagonals of the top of the circle. Okay, so we're given that. That's fine. The three diagonals are shown dotted lines. Each dotted line is 40. Okay, so that's really good. So if we know they're all 40, then this is 20. Yeah. This is 20. This is 20. This is 20. Okay. 20. Slightly tricky actually. Ooh, that's terrible. Terrible, terrible. And this is 20. Okay. We also know angles in a centre add up to 360. Okay, so that is going to be 360. Now there's 6 angles in there. Okay, so 360 divided by 6. You've got your calculator, but you could just do it by hand. So that's going to be 60. Okay, so each of those angles are going to be 60 degrees in there. Okay, now what I think the questions want you to do is to work out the area of a triangle and then multiply it by 6. Okay, so we know that's 20, 20, and 60. I think that's what it's trying to do. That's quite interesting as a question. That's a wee bit tricky. So yeah, because I think areas there, you'd have to be thinking, well, the question's saying, you know, calculate the area. Okay, you know, what have I got? I've got a hexagon. I don't know the area. I don't know how to work it there of a hexagon. So you've got to try and think of breaking it into triangles, and then you're kind of saying, well, wait a minute, how do I, you know, how do I do that? But before you do that, it might have been an idea to say, well, I know the area is a half AB sine C, yeah. And then think, okay, well, I need an angle and 2 lengths. Oh, look, I've got 2 lengths. Oh, I just need that angle. How do I get that? Okay, so try to think how to solve these questions. Something's quite helpful, but just taking your time to apply the knowledge you've got. Okay. So when I started this question, I was looking, going, oh, I'm actually not sure how I'm going to do this. And then once I saw that I had 2 adjacent lengths, I thought, it wants me to use that equation with that angle. Okay, so whenever you see the area of a triangle, it's always, you know, the angle between 2 lengths, and that comes right back to what we were saying before with the cosine rule. Okay, if we call this A, B, and C, okay, this has to be angle capital C, angle capital A, angle capital B, okay, because they're always opposite each other. Okay, always opposite. Okay, and that's exactly what I've got in this equation. That's basically saying the angle in the middle between 2 sides. Okay, if I know that, I can work out the area of the triangle. Okay, and that's what we know. We've got this length, and this angle. Okay, so yeah, let's just solve for that. So we know the area. I'll just say the area of I just say the area. Okay, is equal to a half times 20 times 20 times sine of 60. So 20 times 20 is 400 because it's just 20 times 10 times 2. So 400 and then times by a half is divided by a half. So 400, that's going to give me 200. So 200 times sine of 60 Now, actually, what I'm going to do here, just to remind you again of your exact values, two triangles. You've got your 1, 1, root 2 triangle, which is 45 degrees and 45 degrees. I don't need that. The 60 and the 30 triangle, root 3, 1 and 2. Yep. So for sine of 60, that's going to be opposite over opposite over hypotenuse, so it's root 3 over 2. So if you were doing on calculator paper, that would be the exact value of sine of 60. Okay. Um, we don't have to do that here, that's fine. I'm just showing you that that exists. All right. So if I do 200 times sine of 60, I get 173.2, and we'll call that centimeters squared. Pretty sure centimeters, isn't it? Yep. And just to check, if I do 200 times root 3 divided by 2, I get the same number. Okay, so exact values are quite helpful. These triangles, if you know your SOHCAHTOA, will give you your exact, not all of them, but it will give you 30, 16, 45 for sine, cos, and tan. Okay, so that's what the area of a triangle is. And again, loads of people are going to go, bang, nailed it. Okay, we need to times it by 6. So 173.2 times by 6. That's going to give us 1039.2 centimeters squared. I'm just going to check the marking scheme. Yes. Okay, good stuff. So for this, you're getting a mark for working out your angle. Okay, so actually, yeah, that's great. Working out your angle is 60. They don't give you a mark for demonstrating. I suppose you don't have to. Yep. So you get a mark for your 60, so that's good. You get a mark for substituting in. You get a mark for knowing to times by 6, and you get a mark for your final answer. Okay, so again, 2 marks there out of 4, so half marks. Okay, for simply identifying that the angle in there was 60. Okay, so you could have just tried to work out some angles to see what you got. Play with the diagram, see if you can work anything out. And then substituting for your equation. So 2 half marks for working at an angle and substituting for an equation. But just even working out your angle, 1 mark just for guessing. Oh, I've got no idea what I'm doing, just guessing. Okay. And again, I think if you understood you needed an angle and 2 lengths and it was this equation, just make something up. If you knew 2020, how do I get the angle? I've no idea. Just make up an angle and go with it. You would just lose 1 mark. Okay. So again, always a wee bash. Don't shy away from a question. Certainly when I started that, I wasn't totally sure what strategy I was going to use, but just lay it out, see what you know. You're thinking area, you're seeing triangles, you've got that equation, you know. But yeah, worst case scenario, I'd have just been substituting in numbers into this equation and just trying to pick up anything. Okay. If you put in a half times 40 times 40 times sine of 60, you'd still get 3 out of 4. That's pretty good. Okay. Um, so yeah, I'll have to do this in the next video.